Welcome to the second part of my MIDI Toolkit tutorial. In this tutorial we're going to create a game and then we're going to add MIDI sound effects to the game. So the vast majority of this tutorial is actually going to be creating the game. If you're not interested in creating the game, you can skip to, I think it's about half an hour through. You can check the details of the YouTube clip for the exact time just to see the bits where we add the MIDI information. But we will be building on this game in the next tutorial as well. You're going to need some assets for the game we're going to write, some costumes, and so if you click on the project link which is in the description of this YouTube video and hit the remix button. It's going to be a simple racing game, basically fast tapping on the mouse to make the character run, and that's it. We've got an empty player sprite apart from costumes, and we've got the MIDI toolkit already in here. I'll just go into the MIDI toolkit so that you can see that if I look at the songs, I've got rid of all the other songs. We've just got one song, Yakety Sax, which is the song we're going to use in this project. So I'll go back to the player sprite. I'm going to hit the hide button for the player sprite so that we can actually see what's going on underneath the thumbnail. And as always, we'll start with a green flag block. And I think a nice place to start with this would be to display the player character in an idle animation. So this game is going to run forever. So we'll add a forever loop, and inside that loop we'll call a custom block. So we'll make a custom block and we'll call it update player. And we'll call update player within the forever loop. And in the update player, we're going to alternate between the two animation costumes we've got for an idling player. So let's add a costume count variable, costume counter. Oh, and while we're here, notice in the variables we've got a list of several MIDI variables that are used for the MIDI toolkit and a couple of lists as well. And all of these are used to control the toolkit. And if we look inside the toolkit, then we'll see that we've actually got lots and lots and lots of variables and lots of lists. And this is a beautiful demonstration of the use of for this sprite only variables and lists as opposed to for all sprites. We don't want most of these variables to be accessible outside of the toolkit, so we've made them for this sprite only, which means when we're in another sprite we're not confused by a mass of variables that have nothing to do with this. So it's a good idea to use for this sprite only when you're trying to keep variables to a specific sprite. So back to adding my variable, I was going to add a costume counter. So I'll put costume counter for this sprite only, and I'm going to add a variable called animation counter. Again, for this sprite only. Now, as I mentioned, I've got two idle frames. They're called idle 0 and idle 1. So what I'm going to do in here is I'm going to switch my costume, and I'm going to use the join operator to create the costume name, which will be idle space, and then I'm going to use the modulus function, and I'm going to put costume counter modulus 2. Now the modulus is a remainder function, so this will always give me 0 or 1 for the answer. So I'm going to put that into the code there. So that will always be idle 0 or idle 1, and then when I've displayed it, I will change the costume counter by 1, so it will alternate between the two. And if I run this code, it should already, well, I'll just hit this show button for the sprite. And when I run the code, we can see the player sprite rapidly swapping between costumes. We want them to do it a little bit slower, and this is where animation counter comes in. So every time we come into update player, we're going to change animation counter by 1, and if the animation counter is bigger than 10, we'll update the animation frame. So if animation counter is larger than 10, then we will swap the costume and reset the animation counter back to 0. And I also want to make sure he's positioned correctly. So let's add positional in here. motion, go to, and I'll just put him in the middle of the screen for now, make sure he's there. And if I run the code now, there you go, he's idling at a much nicer, slower speed. And speaking of speed, this is a running game, so I'm going to make a variable called player speed for this sprite only, of course. And this will be how fast he's running. And using this, I can now say, I'll put an if-else in here, because I want him to idle if his speed is 0. If he's not running at all, then I'll make him idle, otherwise he can do a running animation. So I'll just check if the player speed is 0, then he can do the idle. And to make him run, I want to make him go faster the quicker that you click on the mouse button or tap the screen on a touch device. So I'm going to add some code to do this. I'm going to make a broadcast receiver called monitor running clicks. So it's an event. When I receive new message, monitor running clicks, then for now I'll have a forever loop in here, though this will change. So I'll be forever checking to see how quickly the player is tapping the mouse button. So we need a counter. So at the beginning of the main game loop, well, first of all, I'll create the variable. I'll just call it counter for this sprite only. And so I'm going to have to set counter up to 0 at the beginning of the game. And I'll also set up the variables from the update player block as well. So I've got the counter to 0, and the costume counter I'll start at 0, and the animation counter I'll start at 0. And I'll put all those in an initialize custom block. So when I initialize the game, then I will initialize those variables, and I will initialize the game right at the beginning when the green flag is pressed. And in this forever loop, I'm going to increase the counter by 1 each time it goes through the loop. So change counter by 1. So counter is constantly counting upwards. And then when I'm monitoring the running clicks, I can add a new variable called control counter for this sprite only. And you'll see what this is for in a moment. When we first go into here, we'll say that the control counter, set it to whatever counter is. Remember, counter is going up every time it goes through the forever loop in the main game. So I'll set control counter to counter, and then I'm going to wait until the mouse is being pressed or the screen is being clicked. So wait until mouse down. And then I'm going to do a similar thing. I'll just duplicate that line. I'll take that out because now I'm going to wait until it's not down anymore. So basically I'm waiting until it's being pressed and released, because we don't want the player to just hold the mouse button down and run fast. He has to keep clicking it. And once he's pressed and released it, we'll check how quickly he did it. So we can do that because counter minus control counter will tell us how many updates have happened for the mouse down and mouse not down events. So I'll make another variable called click speed, which we're going to use to determine how quickly the player is clicking. And we're going to say that if he's taking more than 15 game loops to click, then the player won't move at all. His speed will be 0. So in the initialized game, we'll set the click counter, click speed, to 15, which is equivalent to just not clicking at all. It's taking too long. So in here, if the number of clicks you've taken, which is counter minus control counter, let's put those in. If that's less than our current setting for click speed, then we're clicking faster than we were before. So we will change click speed. We'll change it by -1. Click speed by -1. We're not going to instantly jump to counter minus control counter. Actually, I've put the multiply in there. I'm glad I noticed that. We're not going to jump instantly to the speed we're clicking because we don't want him to go from standing still to full speed immediately. We want him to work his way up. So we'll do that. And we'll also make sure that having adjusted it, we're not going quicker than you're actually clicking the mouse. So if the click speed is less than counter minus control counter, then we'll just clamp it in place. I'll just copy the counter minus control counter from there and slide it in. And if you actually increase too fast, then we will set the click speed to counter minus control counter. So this is going to allow us to monitor how quickly we're pressing the mouse button. We're going to set this broadcast running right at the beginning, just before the forever loop. So it'll be constantly monitoring how fast you're clicking. Let's put that in there. And we're going to need some almost the opposite, so that if you're not clicking, the player slows down. So I'm going to create another custom block called monitor click speed. And as I say, this is going to, if you're not clicking fast enough, then the player needs to slow down, otherwise he'll stay at top speed throughout. So let's put this down here, and in here, I'm going to borrow this loop because it's going to be similar. No, I'll rewrite it. I'll have an if then, and it's going to be a greater than this time. So if your counter minus control counter, I'll just duplicate it from there. If that's bigger than your click speed, then you're actually taking longer now. So let's slow the fastest click speed down a little bit. So we'll set the click speed, and we'll just slow it down fractionally so that you can speed up quite quickly, but you slow down gradually. So we'll set it, just change it by 0.1. So you don't need set, I've changed there, can't I? Change click speed by 0.1. And that will slow him down gradually. As I mentioned before, at a click speed of 15 is going to be equivalent to not moving at all. So if the click speed has got bigger than 15, we want to clamp it to make sure it can't go bigger than, well, it said 15 is already stopped. So if click speed is greater than 15, then we will set click speed to 15. And from the click speed, we can work out how fast the player is traveling. So we can actually set the player speed from this. So let's set player speed to, it's kind of the opposite way around. When click speed is big, your speed is slow. And when click speed is small, your speed is fast. So we'll flip it around, 15 minus click speed. So instead of when click speed is 15, we'll get 0, and vice versa. I'm going to scale it up slightly. I'm going to multiply it by 2 for the speed we're actually running at. So we'll have that as a player speed. And that is largely it, really. I need to add, into update player, I need to add the animations for running. So in many ways, the running animation is going to be very similar to the idle animation. So I'll just duplicate that block and put it in here. The difference is that we're using run space instead of idle, and that there are costumes 0 to 3. So we modulus it by 4, so it returns 0, 1, 2, or 3, and loops through those. The other change is that we don't want to update his costume every 10 frames anymore. If he's running faster, his costume will change quicker. If he's running slower, his running animation will get slower. So let's introduce another variable called animation speed, which will vary depending on how fast he's running. So we can just set the animation speed to the click speed here. So the quicker you're running, the smaller the animation speed number, so it'll be changing quicker, which is exactly what we want. And we're going to have to make this speed variable proportional with the animation speed. If it's taking 2 frames to go 10 meters, then each frame you want to be traveling 5 meters, for example. So we need to divide the distance by the number of frames it's taking to cover that distance, which is now animation speed. And back in the update player, instead of going greater than 10, we can go greater than animation speed. And I need to make sure that I'm calling our new custom block. So before update player, we'll put in monitor click speed. And let's see if that works. So when you start, he's just idling. If I click the mouse, he starts running. You can see the animation speed and the click speed. As I click faster, they're both getting smaller. As I click slower, he's slowing down. So that's working as we would hope, and then when he slowed down enough, he goes back to idling. Now, my initial thought was that he should be running, he should be moving to the right of the screen as he runs. But he wouldn't have very far he could run then, would he? So I think it's actually going to be better if we put a background behind him that moves to the left. So let's add an update background custom block. And we need a position for the background, so I'll set a variable up called background X for this sprite only. And while I'm here, I'll remove all these variables from the screen. Now the coordinate of the background is going to move left rather than right. The player, consider he's running to the right at player speed, but we're going to keep him still, so the background is going to move to the left at player speed. So every time we call update background, we will change background X by 0 minus player speed. And I'm putting this in the same sprite as player because I'm just going to stamp the costume to the background. So I'll create another custom block called stamp background at. So I'll put stamp background at X colon, add an input X. And this is going to switch the costume to the background costume. It's going to then go to the correct position. So we'll go to X, the coordinate we've passed in, comma 0, and we've already got the pen block in here. So we'll simply stamp the background. But don't forget, the costume is actually used for the player as well, so we need to remember what player he was. So let's just make another variable called player costume. So although it's nice and easy to stamp, we don't want to lose the costume the player is currently on. So at the beginning of stamp, we're going to set player costume to the costume we're currently showing, which is a lux block, and it's there, the costume number. And after we've finished stamping, we're going to set the costume back to player costume. So you won't even realize that it's swapped over. And of course, we need to actually call the stamp background custom block from update background. So we're going to display it at background X. And we'll need to initialize background X. We'll do that in the initialize game block. Set background X to 0. And of course, we'll have to call the update background custom block. So we'll do this just before we update the player. Oh, it's actually running now, so you can see the background just appeared. And the player is, well, let's make this a little larger so we can see. The player is floating well above the actual floor. So where we're setting the position of the player, we'll adjust it so the Y coordinate is minus 138, which is spot on. And let's see what happens when I run. The background's moving backwards, fantastic, and it's gone. So almost what we want, but we're going to need another background to move on as that one's moving off. And that is very simply stamping another background just further to the right, so it joins on with this one. So we'll stamp a new background at background X plus 480, because 480 is the full width of the screen. So now, as the first background moves off, another background should move on. So let's run that. And that background's moving off, and another one's moving on, and then after the new background is gone, we're still running out, but once the new background has come completely on, the first background has moved completely off the left-hand side, so we can recycle that and move it over to the right-hand side. So let's add an if statement here. If, we'll put this under the change background, if the background is less than minus 480, then we know it's moved completely off the screen to the left. And we want to move it over to the right. So we will change background X by 480 to move it over. So we'll keep recycling the screens. And so now, as I'm running, it's moving to the left, and it's just going on and on. If you look closely, you'll see a little distortion happening over this right-hand side every now and then as a screen swap. And the reason for that, I've shown in another tutorial about moving sprites gradually off the screen. So I'll add a little link here so that you can see that tutorial, and I'll just put the fix into the code very quickly. The fix is simply to scale up before moving. So we'll scale up to 1000, and to scale back down again after moving. And now if I go to a large screen and have a look at this, as I run faster and faster, the background moves faster and faster, and it carries on forever. So we now have a beautifully scrolling background and a character who appears to be running. But surely we want to measure how far the character has run. So we'll need to add one more variable called distance. And we'll initialize distance to 0 at the beginning. So in our initialize game block, we can set distance to 0. And as we move, the distance will change. So we'll add another custom block called update race distance. So update race distance. That's going to be a very simple block. All we're going to do is change the distance by the speed we're traveling at. So let's change distance by player speed. And of course, we'll need to call this custom block. So underneath update player, we'll call update race distance. And we'll display the distance on the screen. So I'll just tick the tick box next to distance so that you can see it on the screen there. Go to a large screen, run the code, and let's see how quick he goes. Well, he's 300 meter, 400 meter. He's traveling a little bit too quick there. He's done a kilometer already. So I think we need to make that move up slightly slower. So instead of changing by player speed, let's change by player speed divided by 20. And also notice the way it's displaying there, it looks okay, but it looks like we're just displaying a variable. We can make that look a lot nicer. So I'm going to add yet another variable, and we've got distance already. I'm going to add one called show distance for this sprite only. I'm going to hide distance, but I'm going to leave show distance visible. I'm going to right click on it and change it to a large readout and move it up a little bit to there. So at the moment it doesn't really look any better, but in update race distance I'm going to set show distance, and I'm going to set it so that instead of being 10.497432 or whatever it was, I just want it to one decimal place, and we can do that quite nicely using the floor operator, which removes any fractional part and rounds it down. And we want the floor of distance times 10. The reason being, if we have 10.12, for example, if we multiply it by 10, then we have 101.2. Take off the 0.2, shift it back again, divide by 10, and we'll just have one decimal place. You'll see this when I run the code. Probably easier to show it than to explain it. So floor of distance times 10 divided by 10. So that will give me just one decimal place, which is neater. But to make it even neater, I'm going to add a couple of join functions. Join and join. I'm going to put those into the show distance. So in the first place where it says apple, I'm going to have this race, colon, space, and then I'm going to move this mass function into the next block, and in the final block I'll put space meters. Let's just give that a bit more room there. And you can already see at the top what's happening. If I go to full screen and run this now, it starts on 0 meters, and as it goes up, it's going up at a better speed, and it's looking better. I think that is a far nicer number than having 4, 5, 6 decimal places after it. So now we've got all that working, I think we need a timer, because we want to measure how quickly he can run in 10 seconds. Just going to clean up that code a little bit. And I'm going to add a new receiver called countdown. So events. We now receive countdown. It's a new message. And I'll need a new variable for this message called countdown. And we'll start countdown at 10 for 10 seconds. So in the initialization block, I'll start it with, just hide countdown, I'll start it with set countdown to 10. So we have 10 seconds to run as fast as we can. And in here we're going to repeat until the countdown has reached 0. So repeat until countdown equals 0. And we'll simply wait for a second and then change the countdown by -1. So that's a nice simple countdown there. To make it a little bit more interesting, we could actually have him speak in the countdown. So I could, because I've already added the pen and music block, so I just need to add text to speech. So now I've got that in, we could simply put in here, speak countdown. But the way that would work is, if you look at this when I click the block,
hello.
It speaks hello, but it holds up execution until the word is finished. And so then it wouldn't be waiting 1 second, it'd be waiting 1 second plus however long it takes to say the number. So to get around that, we'll create a new event and we'll say when I receive speak. So by using this in a broadcast, it stops us having to wait for the word to be completed. So we'll speak and then the variable countdown, and we'll broadcast that from here, just before the wait. So the reason for this is just so that we're not waiting 1 second plus the length of speaking the word. When we finish the countdown, I'm going to do two things. I'm going to make another variable called racing for this sprite only, and a question mark because it's true or false. And when we finish the race, the 10 seconds are over, I'm going to set a variable so that we know we've finished. So when we finish, racing is false. And I'm also going to speak a word. I'm going to say finish. So when we've got to the end of the race, I'll say finish. And now I need to broadcast countdown before the race starts. So we'll broadcast monitor running clicks, and just before that, will broadcast countdown. And so now we should have a race that goes on for 10 seconds. But we've set a variable to say it's finished, but we're not doing anything with that variable yet. The first thing I'm going to do with that variable is in monitor running clicks. Instead of being in a forever loop, I'm going to put it into a repeat until. So let's remove the forever, and it's going to repeat until racing is false. Because when we finish racing, we don't want to monitor the clicks anymore. And that's going to have the advantage that once we've stopped being able to monitor the clicks, the player will slow down automatically. So add racing equals false in there. And at the beginning, we're going to have to set racing to true. So there we'll put set racing to true. And let's have a look at this. Set it going.
Finish.
And it finished instantly. Why is that? If we look across at the countdown, repeat until countdown equals 0. We're initializing with initialized counter rather than countdown. That was a silly mistake, so we'll change that to countdown. Go back to the full screen and run it.
10,
9, and it started.
8, 7,
and we can click.
6, 5, 4, 3,
Nearly
2,
there.
1, finish.
And even though I carried on clicking, because it's not monitoring it anymore, it comes to an end. It travels 95 meters. Another small tweak required is that once we finish the race, we don't want to carry on increasing the distance until we come to a stop. We want the distance to be measured exactly when the race is finished. So we only want to be changing the distance if racing is true. Because don't forget, this racing value will get set to false immediately the 10 seconds are over. But the character will carry on running until he comes to a stop. And now I'm going to actually change the way the main game loop works. Because when you finish the race and come to a stop, I want it so that you can start another race just by starting to tap the mouse again. So that you can just carry on having 10 seconds races for as long as you want. So to do this, I'm going to have to take this code and modify it a bit. So we'll start with racing false. So you're not actually in a race when you start, you're just sitting there or standing there idling. And we're going to say, we'll have an if statement in here, right in the beginning of the forever loop, that says, well, first of all, I'll explain, if we don't have anything in there, and the racing is false, then all this code is going to do is put you in an idle animation. So if I run it now, he's idling. He won't do anything if I click because we're not monitoring the running clicks. He's just standing there ready to race. So if racing is false, then we want to check if you've pressed the mouse button and want to start racing. And we're only interested if you're not currently in a race. So if racing is false, but we also want to make sure you're stood still, because don't forget, after a race, racing is false and it waits for you to slow down. You want to be able to stop before you start another race. So we'll put inside there if, and this is going to have an AND operator in it. So if player speed is 0, so you're not actually moving at all, and you've pressed the mouse button, so mouse down, then we want to start a new game. So we can initialize game again. We're starting a new game. We'll set the racing to true because we've started a race. And we'll start the countdown at this point, and we'll also start monitoring the mouse button at this point. So once you've clicked the mouse, the race has started, it starts monitoring the mouse buttons. It will carry on until the countdown reaches 0, at which point the monitoring running clicks will automatically stop because racing is false, and the race should come to an end. So hopefully that will be pretty much a full game. Let's run it from the beginning.
10,
Yep,
9,
started countdown,
8,
and I click the mouse
7,
button.
6, 5, 4, 3, 2, 1. Finish.
And it's got to the end. And when he slows down completely, he goes back to the idle,
10, 9,
and I can start another race. But did you notice
7,
the background jerked
6,
at the beginning of the race?
5, 4,
Or the beginning of the second race? And that is because in initialize game, I'm setting background X to 0. Now, I don't really want to do that. I only want to do that once right at the very beginning, because when I finish the race, I'll start the next race from where I am. So that's initialize game. I'm going to make another custom block just called initialize. So slightly different. And this is going to be called just the once right at the beginning. So I'll take the background X out of here. So it initializes you to the beginning. And then from here, I will initialize game. And so right at the beginning, instead of initializing game, I just call initialize. And that will set the background position and initialize game. And then from that point on, it will just initialize the game variables. And now we have a complete game, except it doesn't do what this tutorial was all about. We have a nice running game. We need to add the MIDI music, finally. So our initialize block can do a few other things now. We'll set the volume we want to play the music at. So set MIDI volume. And this is a value between 0 and 100. So we'll set it quite loud, but not at full volume. And we'll choose a song. We've only actually got one song in this demo, but I'll set it anyway. So we can set the song to song number 1. If we wanted to, we could set it to the name of the song instead. It will work with either in there. What else could we set in here? Any of these MIDI controls. We can look at song count. That will be 1 in this project, because I've only got one song in there. We could look at the length of the song. 0, because I haven't actually run the project yet. Once it's playing the song, that will be how long the song is. Similarly, time played is how far into that song I am. So you can either read that to see how far in you are, or you can set time played to jump to any part in that song. So that's most of the variables there covered, other than visualization offset, which will be in the next tutorial. And so now that's all initialized, we want to actually set the music playing. So initialize is setting it all up, and when it's all set up, all we need to do is broadcast MIDI play. But while we're here, I'll show you these other MIDI commands. We've got MIDI cleanup. That's a useful one to do before you save your file. It will get rid of any data that's used by the MIDI system. MIDI menu is the one that opens up the toolkit and you can add new MIDI music. MIDI play is what we're about to use to start the music playing. Visualizations, we're going to explain in the next tutorial. Song completed callback. That I will show you in a minute what that's used for. It's very useful. MIDI stop will stop music from playing, and finally there's another visualization one which will be covered in the next tutorial. So I'm going to call it MIDI play for now. And now if I go into it and run, I've got some music playing in the background. And if I go back to that variable that was 0 before and look at it, I can tell this song is 114 seconds long. And if I look at time played, I'm 18 seconds in. As I said, I can set that to any value and jump to that point in the song if I wanted. So we now have music playing, which is great. And it was very, very easy to set up. As I expect, it's taken a lot longer to make the game, but I wanted a good game, or a very playable game you could build upon to show this off so you could continue developing it afterwards. But there's something we can do with this MIDI that we couldn't do with a normal sound effect, and that is change the playback speed, which is the one variable I didn't really look at. So this, if playback speed is just set to 1, then the music will play at its normal speed. But I'm going to put this in just at the beginning of the forever loop, and I'm going to set it to a value of 0.5, which is playing at half speed, plus player speed divided by 15. So I'll take player speed up there and divide by 15. So when you're idling with a player speed of 0, this is going to have the playback speed of 0.5, which is half speed. But when you're at full speed, with a player speed of 15, this is going to be 1.5. So as you go faster, the music should increase with you. So it's slow, and as I start to run,
9, 8, 7, 6, 5.
so you can see
3, 2,
the music
1.
reacts to the game, which is something you can't do with normal sound effects. But with this MIDI toolkit, you can actually have the music affected by how exciting the game is or how well you're playing. Now I'm going to add one more thing in here. I mentioned the event MIDI song completed callback, and what happens when a song, if you're playing a song, when it's come to the end, then the MIDI toolkit will actually broadcast song completed, and it's up to you if you want to deal with that or not. What I want to happen is when the song is finished, it just starts playing it again. And that's simple to do because I've already set up the song number, nothing there has changed. So all I need to do is when the song is finished, I'll play it again. And that means you could use this for what you wanted. You could race until the song is finished and end the race then. You could start a different track. You could do anything here. You could fade it out, because you can also fade things in and out by changing MIDI volume as it's playing. So it's up to you what you might want to do with that. But let's go back to the race now.
10, 9,
And we have
8,
a lovely game
7, 6, 5,
where you race to see how far you can go in 10 seconds.
2.
Now, if I were to take this further, then I would make it so it saved the best score in the cloud and the name of the player so that different people could race against each other. I would maybe add obstacles. In the assets, we already have the animations for this crocodile boy to jump. You could put obstacles in the road. There's any number of things you could do in here. So you could play around with the MIDI side of it, you could play around with the game side of it and see what you can come up with. So I think the main thing to get out of this is how easy it was to add the MIDI music at the end of that. And in the next tutorial, I'm going to show how visualizations can be used to react to the music. And specifically for a Guitar Hero type game where you're trying to press keys in time with the music, I'll show how you'll be able to do that. So I hope you enjoyed this tutorial. I hope you enjoy building upon this game that you've created, making it better, making it do much more. I'd love to see how you go with this. Let me know in comments what you do with this, how you've got on, what plans you have for it. Let me know what you thought of the tutorial. And if you've enjoyed it, and I hope you have, then don't forget to subscribe to the RokCoder YouTube channel. And I'll see you again next time.
10, 9, 8, 7, 6, 5,